Okay, now that we have learned the two measures of univariate data, the center and the spread, we're going to take a look at univariate data displays and be able to describe these. Three of the most common displays for univariate data is a histogram, dot plot, and box and whisker plot. And each of these has pros and cons. So just a quick review. A histogram, remember, is a bar graph, but there are no spaces in between the bars. And these bars are sometimes called bins or buckets. A specific value cannot be determined because the buckets are in intervals, and then also the median is not readily seen. For a dot plot, this is best used for small amounts of data because you don't want to have to plot like 100 X's or dots. Um, and the median, again, is not readily seen. The box and whisker plot, remember, comes from our bi-stat summary, so it gives a lot of good information and divides the data into 25% called quartiles. Again, it works best for large sets of data like a histogram. You can see if there's possible outliers, and you can also see the median in a box and whisker. So when we graph our data, we can see how the data is distributed. Sometimes it's clustered together, and sometimes it's more spread apart. You can see on these two graphs, one on the left, this is less spread. And if we calculated the range, it would be 5. The one on the right is more spread apart, and our range would be 9. So the data on the left is more consistent and more predictable than the one on the right. Here's an acronym that you need to make sure that you put in your notes. You're going to be describing these different data displays, and you need to make sure you include each of these points. So SOX is the acronym. So you're always going to tell the shape of your diagram, and we'll get into talking about the number of peaks and if it's symmetric or if it's skewed left or right. Then you also need to identify if there's an outlier or not. If there is, always state what the outliers are, or and also make sure you use those formulas, the upper and lower fence, to actually determine if it truly is an outlier. Then you're going to give the center measure, whether it would be the mean or the median. Recall the mean is used when we do not have an outlier. And the median is used if you do have an outlier, because the median, remember, is a resistant measure. An outlier does not affect your median. So you'll give which measure of center and the actual data value. Then you will give which measure of spread that you should use, the MAD or the IQR, again, depending if you have an outlier or not. The IQR is a resistant measure, so if there is an outlier, make sure you use the IQR, and then you'll state what that IQR or MAD is. So on the first part of describing the shape, you will tell if there are any peaks. So on this one, you can see there's 2 clear peaks, and then on the one on the right, there's just 1 clear peak. The other thing we're going to discuss is if it is symmetric or not. You can kind of see the one on the right is symmetrical, and we may see the one on the left, but let's just get into these two aspects of describing the data. So, and remember again, at any point you need to pause the video, pause it, and get these in your notes. So peaks, it is a graph's local maximums. The data count is clearly higher in a certain section. So let's go through a few possibilities. So like you can see here in graph 1, there is 1 clear peak. So we call that unimodal, one mode. Number 2, you can see there's 2 clear peaks. So we call that bimodal. So number 1 graph is unimodal, second graph is bimodal. Now our last graph is unimodal, but it's also symmetric. You can see the graph. You could fold it in half and it would line up. And so when you have both a combination of one mode and the graph is symmetrical, we just put it together and call it the bell-shaped curve, because you can see it takes on the shape of a bell. And I'm sure you've probably heard the bell-shaped curve term before. If not, you will. Okay, so in these two examples, the one on the left, these science grades, so we can see that these buckets are in intervals of 10. And so we have one grade on the left is always the frequency. So you can see that we have one grade that's between 60 and up to 70. The second one is 3 grades and so forth. But we can see there's one clear peak where 8 grades are from 80 up to a 90. So you have Bs here. So these are your B grades. And we would call this unimodal. Now, I will say that in real life, you probably will never have anything that's exactly symmetrical. So if somebody were to say this is symmetrical and call it the bell-shaped, as long as you just provided why you think it is, there are probably as many, because if this bin right here was included in this one on the left side, it would be exactly symmetrical. So I can see if somebody did call this a bell-shaped curve. On our ELA grades, even though we have C's here and we have A's here, even though the C's are not exactly, this is 7 grades that are C's, and here we have A grades, but it's almost, so you could call that bimodal. Okay, now let's talk about the shapes of our graph. This is very important. So there's 3 different, there's 3 different types of shapes. So we have symmetric. The left half of the graph mirrors the right half. And there's 2 types of images you'll see. And one we've already looked at, the bell shape, but there is another one. Then we have 2 ways that the data plot can be skewed. It means that more data lies on the left or more data lies on the right. And then we have uniform, where it's pretty much the same all the way across. So here are the 2 symmetric displays, the bell shape like we talked about. We can see the left mirrors the right side. Then we have the U-shaped, where the left mirrors the right side again, but it's kind of like it's just a U-shaped, kind of like the opposite, the inverse of the bell-shaped. So in your notes for this part, I would sketch these graphs and not only give it the title, I would also make sure that you know which measures to use. So when you have a symmetrical display, then there's pretty much not going to be an outlier. So you would use the mean for your center measure and MAD for your measure of spread. And the same for the U-shape, because both of these are symmetrical, so you wouldn't have an outlier. Okay, now we have data that is skewed. We have 2 different ways. So the first one we're going to talk about, this is skewed right. So what that means is most of your data is on the left, but then you have this thing that they call a tail, and it's pulling some of your data to the right. So we call this skewed right, which means I have a value, maybe an outlier, that's pulling my data up. Okay, and so it's being pulled to the right. And remember, as you go on the number line, the numbers become more positive. So that's also why they call it typically skewed. So skewed right or positively skewed. And because it's skewed, that means there was probably an outlier. And so that means we're going to use the median and the IQR. So you need to make sure you remember and write this in your notes. This will be on one of your quizzes. And what happens is our mean, okay, because most of the data is on the left, but because we have this outlier being pulled forward, the mean is being pulled past the median, because remember, your median really doesn't change if there's an outlier. So let's just say that the median, we're just going to use it, is 2. And we'll say that the mean and the median start out the same, but because of these values, it's pulling the mean this way, making it larger than the median. So please make sure you have this inequality in your notes. Okay, now let's look at when we have the data that's skewed left. So this is the opposite. So that means most of your data is on the right side, but we do have some values that's pulling it to the left in a negative direction. And again, that means we have some possible outliers. So the best measures to use are median and IQR, those resistant measures. And this time, let's say that our mean and median started at the same, but then we have these negative values coming into play. It's going to pull that mean down and become smaller than the median. So again, make sure you have this in your notebook, that when you have data that is skewed left, that your mean is being pulled left, which becomes smaller than your median. Uniform displays, that's when everything is pretty much the same all across. Okay, so you would use any center, they're all going to be the same, the mean, median, mode. But again, most of the time, if there's no outlier, remember you're going to use the mean for your center and your MAD for the spread. Okay, so let's describe each graph and determine which measure that we're going to use. So you can see this is the number of text messages that was sent, and you can see between 0 and 4, there were 5 times that that many number were sent, and then the same for here. So I'm going to say that this is bimodal because we have 2 clear peaks, and we can see that our data, most of it is kind of on the left side, and we have this tail where it's being pulled down. So I'm going to say that it is skewed to the right. That means my tail is going to the right. Okay, here we have again bimodal, 2 clear modes, but this time most of our data is on the right side, and we have some values that are pulling it down and going to the left. So we'll say that this is skewed left. Remember, it's the direction of the tail. Okay, so both of these are skewed. So in this one, our mean is being pulled up, and it is getting larger than your median. So just in your mind, just always pretend that these two centers start out the same, but then if you have data points pulling it one way or the other, the mean is either going to become greater or less than the median. Here, our mean is being pulled down, so it's going to become smaller or less than the median. Okay, here we have unimodal, 1 clear peak. If you did put bimodal and indicated that these were almost the same, you totally would get credit. So always just kind of explain your reasoning. But for me, I'm just going to go with unimodal for right now. And it is being skewed to the left. It's being pulled to the left. So we're going to say that this is skewed left. And that means that the mean is being pulled down, so it's going to become smaller than the median. Okay, on this one, why don't we just go with unimodal, and it's pretty much almost a bell-shaped, except for this little piece here, but let's just call it bell-shaped. And remember, when we have bell-shaped, it's symmetrical with 1 mode, and so that means the mean is going to be pretty much equal to the median. Okay, let's summarize, and then we will end this part. So when we have a bell-shaped, it's going to look like this, and our mean is equal to our median. When we have skewed left, that means most of the data, whoops, let's back up there. Okay, most of our data is on the right side, but we have a tail that's pulling it down. And so that means our mean is being pulled lower than the median. Skewed right means most of the data is on the left side, but then we have this tail that goes to the right. So that means our mean is pulling, our mean is being pulled past the median and becomes greater. Uniform, it's just pretty much everything's about the same. And so your mean and median would be the same.